PagerDuty just went off. One of your largest customers has an SLI that is extremely unhappy. You're the on-call. Where do you start? Hello and welcome to the InfoQ podcast. My name is Wes Rice, and today on the show we're talking about observability and trying to help answer some of the questions like what I just described. And in particular on the show, we're going to be talking about kind of three pillars of observability. We're going to be talking about distributed tracing. Today, our guest is Ben Sigelman. Ben is the CEO and co-founder of Lightstep. He is the co-creator of Dapper, which is Google's distributed tracing tool. So Ben was part of the team at Google that built the system that Google engineers could literally across the entire stack be able to trace different calls. In addition, Ben is the co-creator of the open source OpenTracing API, part of the CNCF, and is kind of the API for products like Zipkin and Jaeger. Today on the podcast, as I mentioned, we're talking microservice observability. We'll hit on topics like the ELK stack, distributed tracing, and we'll talk a bit about Ben's belief that looking at individual traces is just a start. To really understand the whole picture, we need to kind of start looking at collections and groups of traces. As always, thank you for taking us along on your jogs, walks, and commutes. Ben, welcome to the show.
It's a pleasure to be here. Thanks, Wes.
So let's come back to that story. I just kind of described this like on-call story, and SLI is kind of super unhappy. Let's say you just got paged for a latency-related issue on a service that you're the service owner for, a service level indicator. Obviously, you would want people logging into Lightstep, or you hope maybe that might be part of their solution. But what types of questions should that on-call person be looking to solve when you first start getting paged?
First, my condolences to whomever is on call. It's like the worst feeling in the world. I guess I would step back just for a second and say, what are you getting alerted on? There are different ways to set up alerting, and I think at Google, we actually saw a great diversity of approaches to that general problem of, when do you want to be proactively notified and potentially woken up about something that isn't going well? There were kind of two basic schools of thought. One was that every time something, really bad happens, as part of the postmortem, you set up an alert that would detect the root cause so that next time that root cause is like going in the wrong direction, you get woken up before it goes over the threshold. Another approach on the other extreme was to alert on the actual things that your consumers depend on. So if you're a service in the middle of the stack, you have other services that are calling you, and you would alert on the reliability of what they're calling, essentially. That, in my mind, is basically alerting on SLIs specifically, which is the example that you gave. Although I do see a lot of people alerting on what are basically potential root causes. But it's possible in the situation where you alert on root causes that you're getting woken up for something that's literally irrelevant to your consumers. Like, maybe it turns out that, a year ago you had an outage because some dependency of yours had some issue. And so you set up some alerting around that.
Right.
That situation reappears and you get woken up. And then it turns out that because of some other code change, that's no longer actually an issue in terms of your SLIs. And so the natural thing to do is to say, F this, I'm going to silence this thing until 9 a.m. And you do, and then you go back to sleep. I would just want to say, first of all, if you're getting woken up, it had better actually be an emergency.
Right.
And there are a lot of times, and I've certainly been on on-call shifts myself, where you're getting woken up for things that actually used to be an emergency but aren't an emergency anymore. And that creates this kind of boy who cried wolf situation.
Totally.
So the first thing is, I hope if you're getting woken up, because of the way you set up your alerts, that this is actually an emergency. And you don't have to wonder whether or not you should be awake right now. So hopefully you've done that. So it's a real emergency, which means you're feeling kind of anxious, I think, and you know that you have limited time to fix this. The first thing I'd want to understand if I'm in that situation is, when did this happen? Like, how quickly was it changing? How did it change? That sort of stuff. And then what things in my entire system are correlated with that change? And those things may be in your own service, in which case this is going to be relatively easy. A common situation is that you have a CI/CD pipeline, something got through that shouldn't have, and it goes to production and you roll back. It's a bummer, but you do it. And that's kind of the best case scenario in some ways. The other relatively easy situations are that someone else did a release, but you have to detect that, which in a microservices architecture is actually really hard. We'll talk more about that later. But then you have to detect that and have that thing rolled back. The worst case scenario, I think, of all is that you actually need to write some code and like get the code tested, integrated, and deployed to fix this. Hopefully you're dealing with a rollback of a service or a configuration change, but detecting those and detecting which change is actually responsible for the SLI regression that woke you up in the first place. It can be a very easy thing with the right tools, and with the wrong tools, it can take hours or days.
Yeah.
The challenge, I think, for people moving away from monolithic architectures is that you can't just look at one service anymore to answer the what changed. You have to look at potentially many services that you don't even really understand. And that's what makes it so difficult to be on call these days.
Yeah. I love the fact about making sure it's actually affecting your customer and not just alerting on something that you think is useful. So I mean, we came from the days where we weren't giving enough alerting. So we started our logging, at least. We weren't logging enough.
Yeah.
So we started logging, alerting on everything. And now it's like you get alert fatigue if you're not.
Yeah. I mean, I won't say which, but there's a major Google consumer product, I'll say that their configuration file for alerting, just the declarative configuration file was auto-generated, admittedly, but it was 18,000 lines long.
Wow.
And it was just a monster, an absolute monster. And then on the other side, you had some services that had gotten it pared down to just 12 things that were vital. And they had per second resolution on that stuff. And if there was any indication that it was headed in the wrong direction, people would hop on it. And that was a much saner on-call shift. I'll put it that way.
Yeah, but I can just see, I can envision a talk called the alerting monolith or something.
Yeah, it's actually pretty analogous.
Yeah, totally. There's several things that you just kind of mentioned there in that description that you were just talking about that reminds me of kind of Martin Fowler, a blog post that he did, I want to say 2014. I've referenced it multiple times on the podcast, but he was talking a bit about kind of like preconditions that you had to have for microservice architecture. And in it, he said, you must be this tall for microservices. And he talked about some ideas of, rapid provisioning. So CI/CD pipeline, being able to get things stood up quickly, deployed quickly. He talked about basic monitoring, and he talked about DevOps culture. So is that enough today for microservices, or is the bar higher?
It's of course a matter of opinion, but I think that's all necessary. I don't think it's sufficient personally. The thing that I've noticed in our industry, we're coupling the move to microservices with a move to complete and utter self-determination from a per service team to service team basis, so what I mean by that is that if you're agile 2 pizza or 1 pizza DevOps team, I have actually in the extreme case, I've been seeing some startups that have really gone all in on this stuff, and they have 10 engineers at their company running 500 services. So maybe in that case, the team is like a very tiny bite of pizza, not an entire pizza. But anyway, but you have small teams, we'll put it that way, running services, and then they're left with complete and utter freedom in how they make their technology decisions, as long as their APIs do what they're saying they're going to do. So everyone agrees that you need to have some rigor about the APIs themselves and that those should be stable, but people are left to their own devices about making technology choices. I think that is an incredibly dangerous road to walk. You end up in a place where it does actually work quite well for the beginning, which is the worst thing about it. So you don't find out there's a problem until you're halfway down the road. And then once you have 15 to 50 services, something like that, the fact that you're not able to amortize the cost of having multiple platforms simultaneously being developed at your own organization, it just gets very difficult because there are cross-cutting concerns like orchestration, service discovery, monitoring, security, that sort of stuff that have some dependency on the stack that your engineers have decided upon. And so what I see is people will adopt the DevOps thing and they'll kind of, the metaphor I've used in the past is that they kind of have a hippie ethos about it where everyone just gets to make their own decisions. And then you end up in a world of pain where there's no way to get a global view of anything because you don't have an application layer hook to grab onto to regain some kind of global understanding, either from monitoring, security, orchestration, whatever it may be. I like the idea more individual teams is absolutely making their own decisions about way that they build their software once they've done some kind of multiple choice test about the basic stack that they're using. I don't think it's not necessary in my mind to mandate that everyone at the company uses literally one language and one platform, but maybe you can narrow it down to 3 or 4, and then people can choose the thing that's best fit for whatever it is that they're building.
As you were talking there, that brings up these thoughts about
Libraries we had for maybe circuit breaking or observability, but libraries that we would actually build into the code base.
But over the last few years, with the rise of service meshes, we've been pushing a lot of things down into kind of like the mesh level and kind of pushing them down below. So, what are your thoughts about like libraries versus frameworks and kind of instrumenting at the mesh level?
I'm certainly enthusiastic about it. I think it's a positive thing that the industry has found some way to standardize on some kind of layer 7 technology, some application level technology that provides a single surface area for a bunch of difficult computer science problems around circuit breaking, discovery, monitoring, et cetera. I do think that people have their expectations for what service mesh will deliver are often somewhat unrealistic or inflated. The biggest, well, I may be biased because I'm always, thinking about tracing, but there's an understanding out there that you deploy service mesh, and because it is able to see every call between all of your services, then you can do distributed tracing, because the whole point of distributed tracing is to understand how these calls fit together.
Right.
And unfortunately, that's not true. You are certainly able to understand those individual calls, and that's quite helpful. Nothing wrong with that. However, the most difficult part of getting tracing right from just an integration standpoint is actually not between the processes, it's within the processes. So if you're in a service, you receive a request, you do a bunch of work, and then you make a request as part of the same transaction. The hard part is actually not getting lost in the quote unquote bunch of work. Like oftentimes that involves internal queues or, some kind of batching or whatever it is. And tracing through that stuff is the hard thing. And Service Mesh has no ability to help with that because it only sees the stuff between processes. So I do see people deploying Service Mesh and then feeling a bit confused as to why they don't automatically have a bunch of things. That Service Mesh is doing all that it possibly can, but not everything. And then getting back to the libraries and frameworks thing, I actually think it's kind of interesting. I have a hypothesis that it may sound like this is an anti-service mesh thing. I don't mean it that way at all, but I think of service mesh and containers actually in a similar way, where when containers first became really popular, and I'm not going to say when they're first introduced, because kernel containers are not a new idea. I mean, this has been decades.
Zones with Solaris, LXC.
Exactly. I mean, but when kernel containers became popular in the wider industry, the way I see it was that we all understood that we had to get into a world where it was easier to package and deploy software. And the thing that we were all used to working with was basically a VM, right? A kernel. And so the container was the appropriate way to take that thing that we're already using and move it into something that was a lot more agile and higher velocity. And so it was successful. But my prediction anyway is that, the container, in as much as the container itself is just a VM, the VM is still the wrong programming model. You can see the attraction of things like Lambda or serverless frameworks or microservice frameworks. It's a nicer programming model to think about just your API and your business logic, and not to worry about what distribution of Linux you're using for your kernel container. It's not something you should be thinking about. And I expect that kernel containers will continue to be a vital part of our dependency chain for many years to come. And I also predict that we will not think about them at all. I think it will not be a conversation. I think the conversation will be about the application layer. If we fail to do that, that means this thing is way too hard to program. The fact that we're still talking about containers, to me, means we're not there yet. Service mesh is a little bit like that, in that I think of it as this vital transitional technology. When we're all done and everyone is using mature RPC libraries, I'm not suggesting it has to be gRPC, but something like gRPC. Once things like that are widespread, someone's going to wonder why we're making 4 extra copies of every byte being sent over the network. And they're going to stop doing it because it's insane, from an efficiency standpoint. And they're going to move that stuff into the framework that's probably linked into the application. So I suspect that service mesh will continue to exist, for a very long time for certain workloads. And then for others, my expectation is that just because of the fact that you can't avoid all these extra copies, which end up being expensive, and I have a whole rant about the cost of the network and so on and so forth if you want to hear it, but I predict that the service mesh itself will be a vital transitional technology to move us as an industry towards user space libraries that do a lot of work, a lot more work than they do right now. But service mesh is a more convenient place for this to happen because it's changing so rapidly that you don't want to have to redeploy your application every time the thing gets better. But once it stabilizes, I expect that technology will actually move up the stack and into the process itself and out of the sidecar.
So I wrote down like 4 questions just from that one part right there. But the first part was like a takeaway that I wrote down, and that was just deploying a service mesh isn't going to solve your observability problems. It may show you the communication on the lines between the boxes, but inside the boxes, there's still work to be done. It's not a silver bullet.
Absolutely. It's a very, very helpful
Right.
thing. It's much better than not having it, but I think there's a little bit of a hype curve around it where people expect it to solve their problems. And at best, it's just data. And even that data is really only describing point-to-point communication. And
Right.
since going back to what you started with, you get woken up in the middle of the night, and if it turns out that the issue is several layers beneath you, the service mesh data alone will not really help reveal that. It's too far away.
Right. The question that led us down here was kind of like a polyglot, different technologies, kind of in the stack, in the service mesh environment inside a containerized unit of deployment. Are you abstracted away enough to where it's safer to have this kind of polyglot environment, or do you still kind of feel, even in that service mesh containerized world, that we should still have a very limited number of languages, for example?
That's a really good question. It hinges on the maturity, I guess, of certain things that don't exist yet. Today, I think that's insufficient because you are still dependent on non-standard application layer libraries. Let's just be more concrete. Let's say you're in Java. It's dependent on the fact that you're using Drop Wizard or something like that in order to have a reasonable sense of what's going on in your application. I think that things like OpenTracing actually do help a great deal here, at least for observability. But there are similar things around security, application layer security, and service discovery and things like that containers alone and service mesh alone don't expose, in my mind, enough surface area to really do that stuff well. So I think we either need to see people just choose, again, it's not like it has to be one, but choose a short list of paved path, frameworks for people to choose to build their application, or we need to wait for the industry to develop standards where no matter what framework you use, they support these standards and you can get these basic cross-cutting concerns checked off. But at the moment, we're not in that world. So if you're developing on 12 or 15 different languages, and Lightstep certainly has several customers that are in that ballpark, it's a very difficult thing to develop a coherent organization-wide strategy around monitoring, observability, security, that sort of stuff, when you have such an incredible diversity of languages and frameworks that really don't have a common way of exposing themselves to global concerns.
So the other thing you mentioned was kind of distributed tracing and serverless and some things like that. So I want to come back to that one though. But before we get there, I want to kind of take a little kind of shift gears just a bit and kind of talk a bit about the 3 pillars of observability, and then come back to this idea of serverless and distributed tracing, a few other things. There was a quote that you had in a talk that you gave at KubeCon London, what we got wrong, lessons from birth of microservices. And it was, observability is not about the 3 pillars. That's just data. It's about detection and refinement. So I want to come back to that and just, could you talk a bit more about that?
Yeah, sure. So I'm not a big fan of the term, the 3 pillars of observability, as I guess the quote, that you cited indicates. My concern with it is pretty simple. I've seen a lot of companies, mainly with my Lightstep hat on, some of whom are customers, some of whom I've just talked with, where they went into their observability strategy with that, Three Pillars article in hand where they're like, well, we need to have logs, metrics, and tracing. Those are supposed to, or traces, those are supposed to be the three pillars of observability. So we will check those three boxes and then we'll have observability. And they do. So they check the three boxes and they have logs, metrics, and tracing of some sort. And then they're still getting woken up in the middle of the night, to go back to your initial example, and they're still grasping at straws despite having checked the boxes. And then I think that's a very frustrating experience for them. And it's not that I have any issue with logs, metrics, or tracing. They're all totally important. But in my mind, it's much more reasonable to think of those as pipes than pillars. They're three pipes full of data that you need. It's not like you can discard any of that data without consequences. You need that data for something. But the observability strategy really ought to be focused more around the core workflows and needs for observability, which, as you pointed out, in my mind anyway, are detection and refinement. Detection is about having incredible visibility into your SLIs, with SLI being, the service level indicator, the thing about your service that tells its consumers whether or not it's healthy or not. So it's whether or not you have precise control and understanding of your own SLIs. So that's number one. And then after you have that control of just being able to see your SLIs and understand them, which is the easier part, there's this other task, which is really the lion's share of the work in observability, which is taking the set of tens or hundreds of thousands of possible things that can go wrong in your system and refining that massive, massive search space down to a short list of credible hypotheses for what's going on. Any vendor, including Lightstep, who tells you that you will automatically root cause all of your issues in a distributed system is lying to you. It is not possible. The best thing that we can hope to do is help eliminate hypotheses en masse and to get you down to something that a human being can actually get through in a couple of seconds of, a short list of hypotheses that you can then evaluate rather than starting with the list of 10,000 or 100,000 and using your brain. What's really dangerous and on call, or if you're just trying to make performance improvements, is to rely on institutional knowledge or intelligence. It's a difficult thing to keep that kind of knowledge up to date with the way these systems evolve. And so the tools have to be able to do that for you. And that's the part of observability that's really difficult. I do think that metrics can be really valuable for modeling SLIs and can be somewhat valuable for refining them. Logs, I actually think, are just logging and tracing to me are actually getting to kind of converge in a way, which I can talk about if you want. But in both cases, they're about events at different frequencies possibly. And they are probably more useful for actually really credibly explaining what's going on in a system. So I do think you need all this data, but it's really not sufficient to just say, oh, we have logs, metrics, and tracing and move on. That's not enough.
Okay, that makes a lot of sense to me. A lot of the times you're using logs to prove or disprove some hypothesis, like an issue from an upstream or something. It'd be much more efficient just to kind of focus immediately on proving that hypothesis. But totally by the same token, I hear you that it would definitely be a huge amount of work to cover all the bases. So it's kind of a balance, and you got to use that kind of internal knowledge to be able to focus on what the right hypotheses are. But I also hear that you're not really advocating against logs and metrics. At least I don't think you are. So you're just suggesting we need to really focus on proving and disproving hypotheses, right? So what recommendations do you have for kind of logging done right?
That's a great question. I was at a talk that someone at Lyft gave almost 2 years ago now, actually. Time flies, but he was giving a talk about their use of logging and microservices. And I had a conflict with the talk and I wasn't able to go. So I was really interested and I asked him, what's the summary? What's the summary of your talk? What's your thesis? And he said, oh, it's really simple. Logging and microservices, don't do it. So that was the basic thesis. Of course, he was being sort of glib about that, but the point was basically that if you think of logging, I'll break it down to two categories. There's logging that's about individual transactions, which in a microservice architecture, by definition, are distributed transactions. And then there's logging about everything else. The everything else is usually like your process started, your process stopped, like, that kind of stuff. The everything else is all good. No issues there. And so you should keep on doing that. But it's actually not the lion's share of the volume. If you log about distributed transactions, I can almost guarantee you, at least at scale, you won't be able to afford it in terms of ROI because you're basically taking a logging system like Elk that was designed, the costs in that system were designed in a monolithic era. And then as you multiply out the number of microservices, you're almost linearly multiplying out the amount of logging data you're generating. So if you move to a world where you have 100 microservices, you've basically added 2 orders of magnitude to your logging bill. At the same time, the logging is actually less useful, even ignoring the cost of it, because you need to understand how events in one process affect events in another process, and logging systems weren't really designed to do that. So tracing, distributed tracing, really is nothing more than logging kind of redone for distributed systems, where it's absolutely a log of activity for a transaction. In order to make this work, we have to do some sampling because of the cost issue I mentioned, and we have to understand the causality and the timing relationships between events in different processes, but it's really just a specialized form of logging. So I think of tracing as being the successor to transaction logging. Logging about other things, again, is totally fine, but probably not what you're interested in if you're doing typical investigations of operational issues around regressions that have to do with deploys or config changes, that sort of thing.
Sorry to keep using the kind of 3 pillars of observability as the basis, but what about metrics? Are there any tips that you have for collecting good metrics?
I mean, that one is interesting as well. I would actually go back to what I said a minute ago, that there are 2 types of logging: logging about transactions, logging about everything else. Metrics are sort of the same way. There are metrics about transactions, which from an instrumentation standpoint you shouldn't have to instrument separately for metrics and for traces. In terms of transactions, like if you're trying to measure how long it took to service a request, that should come from the tracing instrumentation. There's no reason for it to come from anything else. There's also metrics about other things like CPU load, memory usage, as well as application level things like how long a queue is, or that sort of stuff. Those metrics do need to be just plain old metric instrumentation. I'd call them gauges. So gauge metrics require specialized metric instrumentation. Everything else, it's about a transaction, if you're doing it right, can come from the same instrumentation you're using for tracing. And we talked about OpenTracing earlier. OpenTracing is actually merging with this project OpenCensus. Our shared goals are really just to find a way to prevent developers from having to tightly couple themselves to any observability choices downstream when they're adding instrumentation, and also to provide a ecosystem of instrumentation for common libraries that will be ready-made for use in production. So both these projects shared those goals, and so it was actually worse for both of us to coexist, and so we're just merging the projects. But one thing I like about OpenCensus is that they from day one had metrics as part of their charter. And I think a mistake we made with OpenTracing was we tried to be as narrow as possible to just make the scope of the project really tight, but I think it was a little bit too tight. It would have been better to think about instrumentation in general and not just tracing instrumentation, because as I just said, the tracing instrumentation really should also be used for metrics. So this new merge project is going to be a constellation of separate concerns around metrics, logging, tracing, that sort of stuff, but they're all part of one well-reasoned, well-factored, decomposable library that can be used in any language that's being used in production. So it'll be interesting to see how that goes. We announced some of that in a blog post a few weeks ago, and there'll be more announcements about it in May. And then this year we'll be doing a lot of work to just create a backwards compatibility layer. But that project should be very helpful, I think, for people who are trying to get an opinionated library that will help them do instrumentation for metrics, logging, and tracing all in one go. So
Awesome. That sounds like an incredible merger and look forward to seeing it. When you're actually building these metrics, what characteristics should you be building in to make sure that they're really effective when you identify something, you can kind of dig deeper and to get to kind of the heart of the problem?
yeah, well, for metrics in particular, I think that the trouble is that you at the end of the day, what you're going to be looking at is a squiggly line in a graph somewhere. And when the line squiggles in the wrong direction, you need to understand why that happened. And the only way you can really do that in a metric system is by grouping by some tag and then hoping that one of the values of the tag is the reason everything spiked. So, to be more concrete, let's say you're grouping by ideally you'd want to do something like, well, my service instance is having a bad time. my service having a bad time, I'm going to group by host name. And then you can see, oh, this one host is the one that's responsible for all of the latency. And so that's where I go and continue my investigation. The trouble is that a lot of those things like host name or container name or customer ID have so many values that what's called the cardinality of the metric gets to be very high. And cardinality is directly proportional to the cost of the metrics. And any metrics vendor will charge you for that because that's their cost. And any open source project will charge you for that as well in terms of the amount of resources you need to devote to the metric system. It's just kind of a law of nature for metrics. And so you end up in this catch-22 where the only tool you really have in a metric system to actually explain the variations that you're seeing is grouping by tags. And then the tags you really want to group by have high cardinality, so you can't. And that's the problem with metrics. I think, again, I'm a little bit over-focused on tracing as a solution to everything, but I really do think in this situation it's incredibly helpful in that in as much as metrics are mostly about transactions and the traces are absolutely about transactions, you can take an intelligent sample of traces and do exactly the sort of analysis that you want to do in terms of high cardinality, group by, filtering, that sort of stuff. And when it's all said and done, you can continue your investigation to look at individual transaction traces, which you could never do with metrics anyway. So it ends up being a much more flexible way to understand particular failure modes in a distributed system, with the only caveat being that you need to have distributed tracing deployed. So there's like an integration process to get there. But I think it's a much more flexible and powerful way to understand systems than grouping by tags that end up being either too expensive or too coarse-grained.
Yeah, very nice.
So you've already talked a bit about tracing being nothing more than logs for distributed systems kind of done right. Let's talk a bit more about tracing. What are some of the common mistakes you see people make that you wish you could just wave a wand and kind of make disappear?
Well, I alluded to one earlier, which is the idea that tracing is a checkbox. It really isn't. Tracing is a data type, and most traces, in terms of just population, are totally boring, like taken on their own. They're often not very large. Like they have, when we imagine a trace, we often think about something that involves hundreds or thousands of services and it's enormously complex. That's one type of transaction trace. There's also one where the transaction was pretty small. It's like it touched 3 or 4 services. And taken on their own, those transaction traces are actually not very interesting or informative. But what's interesting to me is that if you take hundreds or thousands of them, you can find some really profound patterns in that data that are not visible from any other data source. And to me, tracing is about taking traces and doing something useful with them. Going back to the detection and refinement piece from earlier, if you look at hundreds or thousands of traces, you can answer some really important questions about what's changing, both in terms of workloads and in terms of dependencies, with evidence. Instead of it just being a kind of a shot in the dark, you can use that tracing data to generate evidence about a distributed system. But that's only possible if you can consider hundreds or thousands of them in the context of a particular investigation. And that's what tracing should be. But I think for most people, tracing is like a kind of lousy parametric search on somewhat stale data and then looking at individual traces manually, which is a very time-consuming and not very fruitful effort.
You had some thoughts about it. So just looking at 100,000 tracing as a whole isn't necessarily always helpful, right? You had some thoughts around statistics to be able to kind of target how you're looking at these traces, right?
Yeah, the thing that's so cool about traces is that, especially if you're looking at latency or errors, they really do literally understand how individual transactions propagate through an entire system. So if A depends on B, depends on C, depends on D, and D is having a bad day, that will certainly affect A, B, and C.
Right.
And the trace can see that on an individual basis and see that. If you think about them in the aggregate, it can see that and provide a lot of evidence. It's easy to have a computer look at a single trace and understand those relationships and also understand if the latency or the error originated in D or C or B or whatever the case may be. Looking at the statistics of that data can provide, in my mind, very high confidence for what's going on. Going back to what we were saying earlier, you can eliminate huge numbers of hypotheses. Again, let's say that D is having a bad day. You're going to see terrible performance in A, B, and C. Without tracing, you, especially if you're the person responsible for A, you're going to say, oh, dang it, service B, the one I actually know I'm calling, is having a bad day. I'm going to wake that person up so they can fix this. You're going to wake them up after waiting for half an hour. They're going to call C, do the same thing. C is going to wake up and then call D and do this. It's just, and the whole time you're wasting time while you're out of SLI. A tracing system can detect that B and C are innocent here and that they're just basically the messengers of a failure that's further downstream. There's no other way to get that information reliably without a lot of context and knowledge, which again, I think is a really dangerous thing to rely on when you're on call. That's why I like the tracing data.
You were the original author of the Dapper paper that kind of like spawned a lot of this stuff, at least in outside of Google. Today, we've got the OpenTracing API, we've got Jaeger, we've got Zipkin, and we've got, closed source tools like Lightstep and Honeycomb that is out there, our vendors. Can you kind of paint the picture of the landscape a little bit so people can kind of have some of the names and kind of place them in what we're talking about?
Sure. I mean, I'm so utterly biased as the CEO and co-founder of a vendor that I like to try to be pretty concise about my description of the vendor landscape. But in terms of the overall landscape, I see a number of projects that are concerned with integration from an observability standpoint. So Service Mesh can really help with that. OpenTracing absolutely can help with that. As I said, OpenTracing is actually going to be merging with OpenCensus soon. And so you can take either one of those projects actually, and there will be a clean path to this brilliant future of a single merge project. But those things are really, really important. And I think there's no downside to adopting those things. They're in the short term anyway. I think that they're incredibly valuable value adds for getting decent data out of your system. Then there's the matter of actually doing something with that data. So getting back to my 3 pillars critique, they will give you the data from the 3 pillars, but you still need to do something with it. And here is where things get more interesting and more complicated. I guess my overall feeling is that there are a number of vendors who overpromise and a number of open source projects that are somewhat underdeveloped from a product standpoint, which is usually the tough thing for open source. It's hard to get enough people working on UI and stuff like that. So what I would suggest people do is to really think hard about where they are in terms of their own scale. The main thing that vendors don't advertise is what scale they're appropriate for. I have a slide I've used in the past where I say, design your own observability system. You get high cardinality, a long retention window to look back, no sampling, and flexible, ad hoc queries. Choose 3, and that's the issue. And so you can't have all 4 of those things. And I do see vendors that they're not typically advertising that one of those 4 things they don't do. But most of the vendors, and I'll make this into a puzzle for people, don't do one of those things very well. So you can go and figure out which one it is. But if you're operating at really high scale, be careful about future promises from vendors that don't have logos at scale, if that makes sense. And to a certain extent, if you see vendors that have logos that operate at really high scale, there are probably some things that you're going to want to have that won't be available at your scale, and no one's going to be able to provide them because it's kind of a law of nature thing. So I wish that the landscape was a little bit more segmented, less around feature set, but around scale, like the scale of the actual system being monitored. That is the missing dimension in a lot of the analyses I see, and it's terribly important.
Very nice. Okay, so at the very beginning, you talked a bit about distributed tracing, and in this world where we just deploy a function, deploy just your business logic out. What is the state of serverless and distributed tracing today?
That's a great question. I mean, serverless as a category is a little confusing because in my mind, it's defined as a negative. And it's anything that doesn't have a server. It could be anything, right? But if we're talking about functions as a service, like a Lambda, Google Cloud Functions, that sort of thing, Knative, tracing is more important there than anywhere. So it's absolutely necessary. It's a little bit difficult to deploy in some environments, but it really depends on the language that's being used. Node is very popular in serverless, and unfortunately, Node is probably the hardest popular framework/language of all to trace. And I could go into that, but it's a separate question. But that's really more of a Node thing than anything else. I would just say for serverless, tracing is totally necessary. For microservices, depending on how many you have, maybe you can cheat and not have it. But with serverless, it's just a nightmare because everything is so ephemeral. Like you'll never be able to understand stuff without it. And then Node is a bit of a beast, but that's just what it is.
What about like insights into cold start problems with serverless? Your trace isn't going to be able to see that, right?
Well, I think the distributed traces themselves can be tagged with certain information that can be cross-correlated with other information that you have.
Okay.
This goes back to my feeling that distributed tracing is a data source. It's not the end all be all. So hopefully the observability solution that you're using allows you to, you shouldn't have to do it yourself, but hopefully it's able to take traces and cross correlate them with other sources of information. Oh, this was a slow request. It turns out that that's highly correlated with something that's still spinning up and warming up. And then we can tell you that that's the reason why you're having latency issues, but that should be automated.
Oh, right. Nice. Okay. So it's basically enriching a data source.
Exactly.
All right. So I want to start to kind of wrap up. Any final thoughts or recommendations for people that may be kind of working with or implementing distributed tracing solutions today?
Yeah, sure. I think the first and most important thing is to make sure that you choose something portable for the actual instrumentation integration piece. That's getting to be an easier and easier decision as OpenTracing becomes more and more mature. But I think regardless of any other decision, you don't want to have to go back and rip out your instrumentation in the future because you want to switch vendors. You should choose something portable, and that's vitally important. And I think that's becoming part of the conventional wisdom, which makes me very happy. The other thing I would emphasize is trying to think through the on-call scenario that we started with in this podcast, and also thinking through you have a month to make a performance improvement type of scenario, and to really think about the workflows that you want and to choose a stack for observability that is informed by those workflows, and not to be lulled into a belief that any kind of distributed tracing solution will work. I think there are many out there that do just accurately display distributed traces, and then people are surprised that that doesn't solve their problems. So I would try to think back to workflows and use cases and go from there. Lightstep has a bunch of material on our website that's not even really about Lightstep that talks about this stuff. We recently released a guide that also doesn't refer to Lightstep's product at all about how to think about observability and how to score observability. And I gave a talk last December at KubeCon, as well as a talk more recently at QCon, both of which sound very similar, about thinking about observability and how traces should fit into that. So if you want more information, I would probably look for one of those.
Yeah, so two of the talks that have been referred to: restoring confidence in microservices, tracing that's more than traces, that talks about, kind of the mini traces that we talked a bit about and what we got wrong, lessons from the birth of microservices. And then also the original Dapper paper that we talked a bit about, a large-scale distributed system tracing. You can find all those on InfoQ or Google, just search for them. Ben, as always, I love chatting with you. It's like a mind-blowing, mind-opening experience. So thank you so much for taking the time on the InfoQ podcast.
My pleasure. Thank you so much.